Hello students, welcome to Stuti Academy. In today's class, I'll discuss few questions of matter in our surroundings chapter with you. We have already completed this chapter, and if you have any doubt related to this chapter in any of the topic, you can write in the chat box or in the comment section. I'll take your doubt. Now in today's video, I'll discuss few important questions with you from this chapter. Sometimes you get stuck in framing the answers of particular questions. All the concept is clear to you, you know the answer also. But you get stuck when you are framing the answer, when you are writing the answer. And the expression of writing answer is very important. Then only you will get good marks if your expression of writing answer is appropriate. Now today I'll discuss that expression of writing answers and important questions from this chapter. Like question number 1, what is diffusion? Sometimes direct question can come in the exam, or depending on the properties of diffusion, question can come in the reasoning form. So if definition of diffusion comes in the exam, then how will you frame your answer? In this type of question, simply you have to write the intermingling of molecules of one substance with that of the other is called diffusion. It means when molecules of two substances come in contact with each other, then it results in the diffusion. So what is diffusion? Yes, the intermingling of molecules of two substances when they come in contact with each other. So this process is known as diffusion. And if we look at the different states of matter, the diffusion rate is greatest in which state? Solid, liquid or gases? Yes, it is maximum in gases, then in liquids, and then in solids. So the rate of diffusion is maximum in gases, then in liquids and in gases. Students, this question can be asked in exam, like in which state of matter the rate of diffusion is maximum. And what is the answer for this question? Yes, the answer is gases. The maximum rate of diffusion is in gases, then in then in liquids, then in solid. So this is how the rate of diffusion takes place in different states of matter. I'll give you one example. Just take a beaker. In this beaker, add some water. Then add some copper sulfate. And the copper sulfate, which is a salt. What is the color of copper sulfate? Yes, it's a blue in color. When we mix this solid and liquid together, after a certain period of time, what we will observe? Yes, we will observe that the color of the entire water becomes blue in color. So it's not a kind of a magic. It's the intermingling. This is known as intermingling. Intermingling means the molecules of solid and liquid, they diffuse together. They mix it together. When they mix together, it results in the change in the color of water. Earlier it was colorless. But when we add copper sulfate, which is blue in color, the entire color of the water is also blue. So this is due to the process of diffusion. And as I told you, the rate of diffusion is maximum in which state? Yes, it is maximum in gases, then in liquids, and then in solids. It means maximum at minimum. And why this rate of diffusion is maximum in gases? Any idea? Just think, why it is the maximum in gases? Yes, the reason for the rate of diffusion is maximum in gases is due to the arrangement of particles. If you remember, I told you in previous class, the arrangement of particles in gases, they are far away from each other. They are showing one kind of movement. Any idea what do we call that movement? Yes, that movement is Brownian movement. It is Brownian movement. What happened in case of Brownian movement? Yes, the molecules are moving randomly. They are moving from here and there. They are not following any particular direction. So it means in gases, the molecules are far away from each other. They don't like their company, so that's why they are moving here and there randomly. They are just wandering. Yes, so due to this arrangement of particles in gases, the rate of diffusion is maximum. But if we see the arrangement of particles in solid, just remember or recall that class in which I have explained the arrangement of particles in different states of matter. And if you remember, in solid, the arrangement of particles is somewhat like this. They are tightly packed with each other. So due to this tightly packed arrangement of molecules, the rate of diffusion is quite very less. Because when this diffusion takes place, these particles need space to move around. And if they are so closely packed, so it needs more amount of the energy. So that's the reason why the rate of diffusion is maximum in gases and minimum in solids. And if we take an example of liquid, again in case of liquid, the particles are far away, but they are less far away from gases and more closely, they are not that much closely packed as in case of solids. That's the reason why the rate of diffusion in liquids is intermediate, more than solids but less than gases. I hope this question is clear to you. What is diffusion? So on this process of diffusion, on the basis of this process, any question can come in the exam. Might be they ask simple definition of diffusion, or in which state it is maximum, or question can come in this way also, give reason why the rate of diffusion is maximum in gases and minimum in solids. So I hope this question is clear to everyone. So now let's move on to next question. What happens to the rate of diffusion if the temperature is increased? Just remember now what I have told you when I was discussing this question number 1 with you. If we are increasing the temperature, it means if we provide more temperature to the molecules, then what happens? If we are increasing the temperature, the molecules start gaining more energy. Yes, so they start gaining more energy and they start vibrating more. So if we are increasing the temperature, the rate of diffusion also increases. Or we can say that the rate of diffusion is directly proportional to the temperature. On increasing temperature, diffusion also increases. On decreasing temperature, rate of diffusion also increases. If you remember, in previous class, I gave one example to you. When your mother is preparing food for you in the kitchen, the aroma of the food reaches to the other corner of the house. So this is because the hot vapors, they are moving. They are just moving from one place to another when we are providing heat. So vapors are, which are in the gaseous form, they are moving randomly. They are getting more energy and they move at a very faster rate. So the rate of diffusion is directly proportional to the rate of temperature. So I hope this question is clear to you. And how will you present your answer? So you'll write, with increased temperature, the rate of diffusion also increases as the particles gain energy and vibrate more. Now next question is, what is humidity? Humidity is the presence of water vapors. The amount of water vapors present in the air is known as humidity. Or how can you write this answer? The air holds water vapor. When the liquid evaporates, when the water from the ground evaporates due to the heat of the sun, so that the particles of the liquid which are present on the surface, they start gaining energy and vibrating more. As a result, these vapors starts moving up and it converts into the vapors form, in the gaseous form. And the air which is present in the upper atmosphere, it holds those water vapors. And this air with water vapor is known as humid air. And the phenomena is called humidity. So I hope this question is clear to you. So in this you have to simply write down the definition of humidity. Or question can come, what is the effect of humidity on the rate of evaporation? Then I have already explained you in the previous class, humidity and evaporation, they are inversely proportional to each other. So if humidity increases, evaporation decreases. So simply in exam, definition of humidity can come, or the rate of evaporation, how it depends on this humidity, that can also come. So it depends on the question, what type of question can come in the exam. On the basis of that, you have to write down answer. Let's move on to next question. What will happen if the pressure is reduced on solid carbon dioxide gas, which we call dry ice also? And this solid carbon dioxide gas, ice cream sellers use this dry ice in their container in which they keep ice creams. So that's a solid carbon dioxide gas. And the question is, what is the effect of pressure on solid carbon dioxide gas, which is present in the solid state? Here dry ice means it is present in a solid state. So dry ice is which state? Yes, it's a solid state. And when we reduce the pressure, when we lower the pressure, then what will happen? If we reduce the pressure on solid carbon dioxide gas, it directly changes into which state? Yes, absolutely. It changes into gaseous state without melting. It means it will not go to the liquid phase. It directly changes from solid to gaseous state. And this process is known as sublimation. When solid directly changes into gaseous state, when solid directly changes into gaseous state, this process is known as sublimation. We'll study about this process in detail in chapter number 2, which is matter around the sphere. So here I'm just giving you a brief introduction of this process when the solid directly changes into gases. So if we reduce pressure, solid carbon dioxide gas, which we call dry ice also, it changes into gaseous form, which is a carbon dioxide gas. And the formula for carbon dioxide gas is CO2. I hope this question is clear. Now the next question is, sponge is solid, but we can still compress it. Why? This solid is this sponge is a solid form, and again we are saying that solids cannot be compressed. But sponge is a solid. How can we compress it? What's the reason behind it? Any idea? Have you ever seen sponge? I hope you all are using sponge in your house. We wash utensils when we are using sponge. Yes, sponge is a solid substance which has some pores in it. It's like this. I'll just show you here. Now today you'll go and check in your kitchen. When we use this sponge for washing utensils, they have some pores on it, like this. And due to the presence of these minute pores, here pore means holes, they have some holes on it. And due to the presence of these pores, air can easily pass through it. Air is present into it. Air can easily enter into these pores, and when we compress it, it's released out. And that's the reason we can easily compress the sponge. We use dusters, and on that duster also some sponge is there. We have some sponge on dusters which we use for rubbing or erasing anything on the boards. So that's also an example of a sponge. So a sponge has those solids which have some minute pores on it. And when we compress it, so when we are compressing, due to the presence of those small holes, so air can easily release out. And that's the reason why we can compress it. So those solids which have pores, we can compress. Otherwise, we cannot compress solids. Again, what is the reason why we cannot compress it? Because due to the arrangement of particles. So I hope these questions are very much clear to you, and these are very frequently asked questions which comes in the exam. And how will you represent their answers? So in this manner, you'll write your answers, and definitely you'll get full marks if you write answer in this manner. The concept should be clear to you. If you still have any doubt, you can ask. So I have discussed these questions. What is diffusion? What happens to the rate of diffusion if the temperature is increased? What is humidity? And what will happen if the pressure is reduced on solid carbon dioxide gas, which is a dry ice? And sponge is solid, but we can still compress it. Why? So in this you have to give reason. I hope students you like today's class. Thank you everyone, and thank you for enjoying the session. In next class, I discuss few more questions with you from this chapter. But before that, just go through the chapter, go through each and every topic thoroughly, And if you are facing any problem, you can ask. Thank you everyone.